Hi, and welcome to video 3 for section 1.8. This is the third of 3 videos. In this video, we're going to be looking at 2 examples. Both of these examples likely to show up on your in-class exams or the final exam. So, watch these a couple times if you need to. Make sure you're following the steps. If I go from one line to the next and something isn't quite clear, back the video up, watch it again. Take down notes, take down any questions you have. Come on to class, feel free to ask them at that point, and we'll do more of these examples in class, but I at least want you to see two of these types of problems so that if you need to go back and reference, you can. So the first example, given that the tangent line to a circle is perpendicular to the adjoining radius at the point of contact find the equation of the tangent line to the circle x squared plus y squared equals 25 at the point three, 4. This problem is a problem, right? Especially if you've never seen it before. All of a sudden you're sitting in the final exam and you get this problem and you're like, what in the world are they asking me here? I have no idea. Or even if you're on your homework and you're working this on the homework and it's like, I don't even know what this problem is asking me to do. I'm just going to skip it and I pray to God it doesn't show up on the exam. Well, I'm telling you now, it's going to show up on the exam. So you need to know how to do this kind of problem, but that's not really an issue now because we're going to do it here. We'll do some more in class. But what this question is really asking or telling us is we have some circle and we have some tangent line. Tangent line means that it's making contact with another line just at one point. And the tangent line is perpendicular, means it makes a right angle to the adjoining radius. So from the circle, the radius out to this point, where it hits the tangent line, that becomes a perpendicular angle. Now, something that's not even given to you in this problem, and so I guess they maybe expect you to know it, but the slope of a tangent line is the negative reciprocal of the line perpendicular to it. Well, so in this case, so the tangent line is the negative reciprocal of the slope of the radius. That's probably a better way to do this in this specific case. But if we ever have a tangent line, and if we have the slope of a line that's tangent to it, if we take the negative reciprocal, so let's say that the slope of the radius, so I'm going to put slope r, is a over b. The slope of the tangent line is equal to negative, the negative reciprocal, and then flip it, b over a. So there's that property that we have to know, again, before we can even do this problem. So to find the equation of a tangent line, the first thing we need to know is what's the slope of the tangent line. And so to get that, we need the slope of the radius. So how can we figure out the slope of the radius? Well, it told us here that what? We have this circle. X squared plus y squared is 25. That means what? The radius is 5. Our point is 3, 4. So we're up here. We have this tangent line and the radius. And these guys are perpendicular. Well, this point is what? This point is 3, 4. And how do I find slope? Well, I do what? I do y2 minus y1 over x2 minus x1. So I have another point here, which is the origin, which is 0, 0. So the slope of the radius, and m is our short notation for slope. So the slope of the radius, m of r, is equal to, let's call this x2, y2, x1, y1, so we can keep it straight in the formula. So the slope of the radius is y2 minus y1 over x2 minus x1. And again, they have you come into this class expecting you to know how to find slope of lines, use point slope formula to figure out equations of lines that we'll need here as well. So the slope of the radius is what? y2, which is 4, minus y1, which is 0, over x2, which is 3, minus x1, which is 0. So that's 4 over 3. That's the slope of the radius. So the slope of the tangent line, we'll call it m of t, is the negative reciprocal of the slope of the radius. So that's negative 3 over 4. I just flipped that number. 4/3 is now 3 over 4, and it has to be negative. Now, so I know the slope of this line is equal to negative 3/4. So to find the equation of that tangent line, which is what we're looking for here, I need what? Point slope formula. So you should have this probably on your cheat sheet if you don't remember it. And then point slope formula tells me that if I have one point and the slope of a line, I can figure out the equation of the line. And it's y minus y1 equals m x minus x1. And this y1, x1 doesn't mean the x1, y1 that I picked here. It just means the point of the line that I'm looking for. So in this case, I'm going to be using 3 and 4. So I have the slope, negative 3/4. I have a point that's on this tangent line, 3, 4. So I don't care that I called these y2 and y1 anymore. I'm just worried about the point that's on this line, which is 3, 4. So if I plug those in, I get y minus y1, which is 4, equals the slope, negative 3/4, times x minus x1, which is 3. And now I just need to distribute and move all the pieces so I can get the equation of a line. So I get y minus 4 is, distribute this negative 3/4, so minus 3/4 x. Negative times negative is positive. 3 times 3 is 9, so 9/4. And then I want to add 4 to both sides. But because I am adding 4 to 9/4, I really need this guy as a fraction. So that's what? I'm actually adding 16/4 to both sides. So when I do that, all I'm left with on the left is y. Whoops, there should be an x here. Minus 3/4 x. So that negative 3/4 times x gives me minus 3/4 x. And then plus 9/4 plus 16/4. They have the same denominator, 4, so I just add the numerators. 9 plus 16 is 25. So the equation of this tangent line, which touches the circle at the point 3, 4, is y equals negative 3/4 x plus 25/4. So you can see a lot of concepts you need to know, a lot of work you need to do. That's why this is a big point problem on your exam. So again, make sure you understand it. If you have any questions about, well, how did I get this, or where did we get that number for, or why did we do this process, try to watch the video again. Hopefully I pointed it out. If I didn't do a good enough job, that's fine. Come to class, have it highlighted and say, hey, you know, in the tangent line example, how did you get this value? Or why did we use that formula? And I'll try to explain a little better then. So anyways, if you need to catch up or kind of follow back through, go ahead and hit pause. I'm going to erase this. We're going to look at one more example. So this next example we're going to be doing, we're going to be going back to, from video 1, the standard form of a circle. So this example, we want to show the equation x squared plus y squared plus 2x minus 6y plus 7 equals 0 represents a circle and then we want to find the center and the radius. So you're given this equation. Someone says to you, well, what's that an equation of? You say, oh, that's a circle. Okay, well, show me. How is it a circle? Well, we need to put it in standard form, and then once it's in standard form, we can use that to tell the person what's the center and what's the radius. So remember, what was standard form? It's x minus h squared plus y minus k squared equals r squared. So here's how you have to solve this problem. Complete the square. I know it's not everybody's favorite technique. Here's more bad news. You got to do it twice. So we're going to need to complete the square once to get our x piece. We're going to need to complete the square twice to get our y piece. And then whatever we're adding or subtracting from each side, from the left, we need to do it to the right. So the first thing I'm going to do is rewrite this guy. We're going to rewrite it with the x pieces together, the y pieces together, and the numbers all on the right. So I have what? I have x squared plus 2x. I'm going to leave some space here. And then what? Plus y squared minus 6y. Whoops, let me do that in green instead so we can keep track of our x pieces and y pieces. So x squared plus 2x plus y squared minus 6y. And now what I'm going to do is move the numbers over to the right. So I have 7 here, so I'm going to subtract 7 from both sides. So I get negative 7 on the right. So let's complete the square for the x part. So if I do that, what's the process? Well, I have to say b is what? B is plus 2. 1/2 of b is plus 1. And then if I square that value, plus 1 squared is still plus 1. So I'm going to add 1 in here. That's why I left that space. So now I have x squared plus 2x plus 1. But what did I do? I changed this equation now, right? I added 1 on the left. So because I added 1 on the left, I also need to add 1 on the right. Again, remember that teeter-totter? So I just added 1 over here. I need to add 1 on the right to keep it equal, to keep it in balance. Now let's do the y pieces. So my b is what? B is negative 6. So 1/2 of b is negative 3. So 1/2 of b, that value squared, negative 3 squared is positive 9. So I'm going to add 9 over here. which means I need to add 9 on the right. Keep everything in balance. So now, let's look at the x part, the part in blue. Well, I know I can now write this as a binomial squared, right? This is what? If we use our trick we had before, whatever 1/2 of b is, that's the number that goes in here. So this becomes x plus 1 squared. Is this part in blue rewritten as a squared value? And then plus, it's y something squared. Well, what value goes in there with the y? It's this one. 1/2 of b is -3. So this gets a -3. And then what's on the right? -7 plus 1 is -6, plus 9 is +3. So now we have what? We have the standard form of a circle. So there's my standard form. There you go. I've showed you that it represents a circle because here's its standard form. Now my center is at what? I see +1, so it's -1. I see -3, so it's +3. So my center is at -1, +3. And lastly, what's the radius? Well, the radius is the square root of whatever's on the right, so square root of 3. I don't have a nice number like square root of 25 is 5, so I just leave it as the square root of 3. It doesn't say graph or sketch, so don't waste your time doing that. But that, if you're given that as a problem, that's how you solve this type of problem. Now, hopefully, in class or in the homework, there's a problem that'll have something like maybe 2y squared. And so I'll show you how to do that. Don't forget, before we complete the square, this number here has to be a 1. So if it's anything other than a 1, we need to divide that number out, but then when we start adding numbers on the left or right, we have to handle it a little different. So I'll make sure that we do an example like that in class. And again, that's why we do this flipped class. I don't want to waste a lot of your time going through that type of example, but you do need to know how to do it. So we'll do that in class. That wraps up the third video. 2 types of problems you'll probably see on an exam, or very likely we'll see on an exam. So come on back, we'll wrap up chapter 1 with section 1.10.